Hello, I hope you're doing great. I'm back with another video from the Pinterest YouTube channel. In this video, we're going to look at how I managed to access over 1 million different people's social media accounts and earned a $7,500 bounty for it. Of course, honestly, the real value of having access to 1 million accounts is probably, and it's not an exaggeration to say, more than 100 times that $7,500. That's because in those accounts, different people's social media accounts were linked or assigned to that web application, and with that, you could run all sorts of ads. You could even pump or dump cryptocurrencies and do all sorts of other scenarios. But when you become an ethical hacker, when you learn how to control your own abilities and have the discipline to handle certain types of access, naturally you never even think about these things. Maybe after reporting, after the vulnerability is gone, you might think about what you could have done with it, but naturally not before that. Alright, let's get into how step by step, I'll explain the process I went through to find this vulnerability. One thing to note is that this vulnerability was found during one of the live mentoring sessions at Pintesterland Academy, and naturally, during that live hunting session we had, which lasted between 8 to 10 hours. Everything was thoroughly examined there, and the participants got to see in full detail exactly how I personally conduct a security assessment. But here, we're just going to briefly and concisely go over the workflow that Reza Sharifzada follows. First of all, when you want to work on a web application that's a single application, and it's a web app where you can sign up, log in, and do various things, you should start by considering the business aspect of that application. If it's B2B, think about what unique behaviors you can leverage. Most of the applications we work on, by default, are B2C, meaning it's a business providing services to us as customers. But sometimes, applications might also have a B2B plan, where certain functions are triggered for you and some access is granted, allowing you to carry out different types of attacks. For example, with one of the big companies, I was able to earn nearly $10,000 in bounty thanks to this B2B aspect. This is definitely going to be the topic of another video on the Pintesterland YouTube channel. So, the first step is to understand the business of that application. The business of the application we were working on was B2C. It worked like this. You would sign up, pay a monthly subscription, and through that application, you could manage all your social media accounts on Threads, YouTube, Instagram, LinkedIn, Pinterest if I'm not mistaken, and a bunch of other things. And well, you could also add sub-accounts and a lot of other features. Now, after that, we'll move on to see which functions are available to different users. Let me mention an important point. In the application we were working on, you had the ability to add an organization and, under that organization, analyze different users with various roles. An important point is that, especially if you're a junior or mid-level hacker, you really need to work on this. Create users with different access levels and try to escalate yourself from a lower level user to a higher level user, or call functions that make you appear as a higher level user. Of course, in the scenario I demonstrated, naturally there was no need for any interaction or additional access, and basically, I was a user from another organization and could practically compromise any other organization. But for those of you who are at a lower level, this trick can really work well. All you need to do is call all the APIs once with a user who has higher level access, then change the token to that of a user with lower level access and see if the calls still go through or not. And well, this in itself is a type of vulnerability. Naturally, its impact is much lower compared to cases where you can do something without any access or extra privilege. But still, it's one of the really interesting test cases. The third case, when I call functions, guys, I pay a lot of attention. For example, if I manage to find a vulnerability in a specific function, which is this third step, I consider what impact that vulnerability has. I categorize my test cases based on this. What does that mean? It means I look at it like this. Okay, here we have 10 functions, and each of these 10 functions is supposed to do something different. One of them reads a specific piece of data, another one modifies it, another creates, another deletes, and then I ask myself, Reza, if you run a byte on this particular function, maybe its impact is P1, but if you run a byte on another function, maybe its impact is P3. So, Based on the priority, what priority it has, I start executing my test cases accordingly. So, test all the functions of the web application, analyze them as a regular user, and see if there's a vulnerability there. We still don't know if there is or not, but let's assume there is. Which one would have the higher impact? After you analyze the functions, you can then consider what threats and what kinds of attacks might be possible. There was one point to note. Well, naturally, since this application was for management, you could add posts in it, schedule your posts, that is, set an appropriate time for them, and do anything else you wanted. The important point is, when I think about this function, how does that application actually go about posting my content? Probably, when my post is scheduled, pay close attention to this point. When my post is scheduled, it needs to be placed in an object, in a section where it will be called at a certain time. And in that section, what data needs to be there, guys? Naturally, my social media token needs to be there, because with that token, the post is supposed to be published on Instagram or somewhere else. So, that's how the function is understood. Let me tell you something. There were 5 ways to post, story, and all of them were ad secure, but in the case of Reels, there was an insecurity. Pay attention. I checked all the other functions that were similar to Reels, and they were secure, but Reels itself was vulnerable. That is, when you wanted to upload a Reel, which was only for Instagram accounts, this vulnerability existed. So when you feel like different functions are similar, never say, well, I tested one and it's secure, so the rest will be secure too. No! Let me mention something. This account was a program, a public bot program with code. It was a program that had been worked on for years, evaluated, and had received a lot of reports. There were over 60 broken access control authentication reports just on this application, and I can say this was the most important vulnerability of the app. It was reported by me about 2 weeks ago, so it's really important that if you're going to run a test, you do it on all the functions, not just say, well, the add post function is similar to the story function, so I'll just test one and skip the other. That's completely wrong. Maybe they're all secure, but the correct and proper way is to test each one separately. What's the 5th step? I, Reza Sharizada, need to understand every single character that goes out from my side in every request, and every single character that comes back to me in the response. One issue that a lot of you have is, for example, when a request body is being sent from your side, you just go and change some fixed values. That's a mistake. When you want to perform a security assessment on a request, you need to know what every single parameter in that request is for, and also what is being returned in the response. And you should analyze the entire response as well. Why? Because sometimes, using the mass assignment vulnerability, we can take keys that appear in the response and use them in the request to exploit the system. So it's really important to know exactly what every variable and parameter that's being sent from your side is actually doing. And next, let's take a look at the following point. Okay, now we understand what the function does. The function is supposed to add posts, add stories, add reels, and we check the variables. Naturally, if I can figure out what this function does here, I can start thinking about what could happen if I find this vulnerability. If I find a vulnerability in this scenario, let's think together about what would happen if I could post a reel as another user. And since in the response to my own reel, I can see the Instagram token. So if I can post a reel as another user, I can actually even see their token and then use that token to make posts as well. It means it's not just limited to reels, and that's really interesting. Of course, guys, let me say that this was also part of the app's security configuration, and the developer could have set it up so that the token wouldn't be shown in the response at all, and then the vulnerability would only affect the integrity and have an effect there, so to speak. But because the token was also being returned, it affected both integrity and confidentiality, and in my opinion, it went way beyond just the typical CCSS discussion. I mean, scoring it with CVSS doesn't really make sense, because from a business perspective, we could easily say its score could be 10 out of 10, since it could have a huge impact. So what have I done so far? I've understood the functions. I figured out what each variable that goes from me and comes back is doing. I asked, if this vulnerability exists here, what could happen? Now, let's move on to see how we can test this. Look, one of your main weaknesses is that you don't spend enough time on your tests. Meaning, when you see that an application has the ability to add LinkedIn, Instagram, Facebook, and a bunch of other things, you don't go and actually add them. One of the important things you need to do is, guys, spend as much time as possible on this. Personally, when I want to do a logical security review on an application, I go ahead and create several accounts. I mean, on this very app that I'm explaining to you, I probably had over 20 or 30 accounts, and each time I would test different scenarios, and every time I would find something new. So don't think that even I, when I go after a target, get everything done on the first try. No, a lot of times I might go back to the target a week later and realize I missed something. So always keep this in mind. So I understood the function and I understood the variables. Now I moved on to our ding that function. Well, I did the same things for posts and stories, but it didn't work. I'll explain reels directly so we can have a good summary. I went ahead and added a reel. Then I saw that there's an option to add a reel. In the response, it's giving me a container ID, which is actually written incorrectly here. Let me fix this. It returns a container ID for me. And what was that container ID actually referring to? I want to tell you the exact point of this vulnerability. Look, when you added a post, it would just get published on your social network and that was it. But when you scheduled a post, or a reel, or a story, a container ID would be returned in the response. And that container ID was actually an isolated environment related to that post. Meaning, if you referred to that container ID, you were basically saying that user so-and-so has scheduled this post for such and such time, and it's supposed to be published with these tokens at, say, that specific time. So, the container ID was a really important concept that allowed me to reference different posts, stories, and reels. So what was the point of all this? I could update the container ID, but when I did and set a put request, it was secure and wouldn't let me change the container IDs of other users or see any extra data from other users in the response. But when I was creating that post, story, or reel, in this scenario, only reels were vulnerable. I could manually add the container ID while adding a reel. Basically, I performed mass assignment. What I did was, I posted something once, and then in the request for my next post, I put the container ID of my previous post. I saw that instead of creating a new post, in this case, a new reel, it actually updated the previous one. That's when I realized that even though the main put itself, meaning the main put, its route was like this. For example, the path was /user/container ID so that the container ID would get updated. But when I called the route for creating reels, I could add the container ID to it. And instead of generating a new container ID for me and actually creating a new post, it would go and update the previous one. So here it occurred to me to combine mass assignment with A2. I went ahead and, using user_b, created a post, set up a Rails app, and then called the container ID of user_b, that is, the Rails instance related to user_b with user_a. And I saw that, oh, the post related to user_b had changed, and more importantly, in the response, I was seeing the Instagram token that specifically belonged to user_b. And I was able to demonstrate this really nicely. Now let me tell you an important point. Because, as I've written here, the container ID that I have found was enumerable. Meaning, you could change the numbers one by one and access information of other users. Naturally, this was an insecure direct object reference, IVR, vulnerability, and I could have dumped all the tokens. Of course, I didn't do that, but just to give you an idea of its significance, that's how serious it was. Here, I've also included a sample request for you. You could edit the Rails at such a path, and it would have data like this. Naturally, everyone usually comes here and changes the account ID, but no, in this scenario it wasn't like that. And then I put in my own container ID. I saw that, yes, the information for my own container ID was also being updated. So instead of just creating, it also updates. Then I entered the container ID related to my second account, and I saw that, yes, I was able to affect the post, story, or reel belonging to my second account. What was the important point? It was that, although I was sending a request to Rails Media, I could actually affect all posts, stories, and anything else on any social media. Why? Because the container ID wasn't restricted to a specific function. Instead, all functions in the database had access to that container ID. But in other cases, it was secure and made sure, for example, that user A's container couldn't access the container IDs of other users. But in this function, that security wasn't there, and it was vulnerable. I hope you enjoyed watching this video. If you've made it this far, don't forget to like, comment, and share with your friends. And definitely, if you haven't subscribed yet, make sure to subscribe so we can bring you even better and more beautiful content in future videos. Until the next video, take care and goodbye.